Hi, in the last video I showed you how I set up Python on the TXT controller. Now I've started a terminal in which I have gone to the TXT controller again. And to start a script, last time I used, let me go to it. It was quite a long, it was this command, and it is quite an effort to type it all in. So what I did was take this whole part and put it in a separate script, so that I only have to call that script and add the file name. So I call that script run Python, and you can see that this is the first part of that command, and I added $1, which in Unix and Linux means an argument that can be given when you start the script. So let me exit this script, and as we can see, this is still the simple demo explorer.py, and if I run Python and I type in as an argument simple demo explorer, it runs. So that is to make things easier. Now we can use VI, which is a basic editor used by all Unix versions, so also Linux. And this is the simple script. Import system. With import you make use of libraries, in this case sys and ft-robopy. And what we see here is that there are variables, and you assign txt.motor1, which is the first motor. So in this case, motor rechts will be the same as motor 1. Ultrasound is the same as the ultrasonic, which I do not have yet. And in this command you put the speed of both of the right side motor, rechts is right side, to its maximum speed of 512. Same for the left side motor, and here you give the command to go for a distance of 100 pulses. You don't run with this controller in distances, centimeters or so, but in pulses. So what I will do is add a third motor, and although it only has 2 wheels, the lamp, which you could see in the first videos as well of this controller, is connected to the third motor. So I call it simply motor 3 is txt.motor3. Then I will reduce the speed for this example to the half, so instead of 512 it will be 265. 256, sorry. This one as well. And let's say this, while motor right is finished, while not finished, I will light the lamp in the end. So what I will do is and I will say set speed to let's say 256, which is half speed, and then it should light for half brightness. So let's see what happens. I save and quit the editor. Then let's turn the camera towards the controller. Let's see what happens. And it drives slowly for a little bit and the light goes on and off. I'll do it again. And this way you see that a simple change in code makes it work nicely. Of course we can do our adaptations as well, like let it run for a longer time, but also if you want to make a turn, then you need one of the motors in reverse speed. So we add a minus here, so the right side motor will run half speed, but the other way. And well, let's start with this. So let's turn the camera again towards the controller. Ouch. Okay. And you see it turns a little bit, which is all due to the reversed speed of the right side motor. And of course we can change the distance by replacing the 100 into 200. And it does a little bit slower, which is because a double distance does not mean that it really goes twice as far. I will have to look that further on. So let's turn the camera again into Python. So here you assign the distance which is measured by the sonar, which I don't have, to the variable d. You print it, and if it is smaller than 10, you stop the motors and you sound the bell, light the lamp now, and you wait. And here you can see quite clearly that the distance is 0, which is logical because there is no ultrasound yet. Unfortunately, the camera is not yet implemented, so let's see what we can change next. Let's change the 1 into 2 right here. TXT play sound 3, 2. It wasn't that clear. Let's make it 3. See what the difference that makes. Should sound louder. And if I change this one into a different one, for example 1, let's see what happens. That is very different sound. Oh, it may be that it doesn't sound longer but louder. Let's change this one back to 1. Very different. One last attempt. Let's see what sound 2 does. Ah, sounding an alarm. So this is just experimenting, as I haven't done this before. So you see it as I see it for the first time, which is quite fun. And by the way, this is straight on the controller, so this is truly embedded. Let's see what happens again if I put this to 3. And let's put it back to the controller. Okay. I guess I'll experiment a little bit more and have to buy the ultrasound, the sonar, and wait for implementation of the camera. So you see, it is always fun. To experiment with some real programming. And if you would like to have some more experiments, please let me know. On my website is you can find my email address, and I appreciate the donation. Thank you for watching and listening, and see you next time.